Okay, you're right. Welcome to your video tutorial. Today we are going to look at terminating and reoccurring decimals and just a quick revision on how to round. Look at this little guy. Look how stoked he is to be doing this. Look at his little face. Okay, decimals that stop, or terminate as we call it, are known as terminating decimals, whereas decimals that continue on forever in some form of pattern are repeating or reoccurring decimals, and they're the two we're going to look at really quickly. We're going to use some of our information from previous lessons in order to convert a few of our decimals. Okay, so convert the following fractions to terminated decimals. Okay, you know when I write 1 over 4, that means 1 divided by 4, okay? And hopefully you should remember a quarter as its decimal is 0.25. 0.25, that is just something that you need to remember. If you can't remember that off by heart, that's okay. That's not the end of the world. I'll show you how you can actually work it out. Because that line means division, I'm saying 1 divided by 4. Now, you might note that I've just written the 1 in there. The first thing I do is how many times does 4 go into 1? It doesn't. I usually put a 0. And then what do I kind of do with everything else? So it's really important that when you do a division like this, if you're trying to work out the fraction to the decimal, that you actually put in a decimal point and some zeros. Okay, you can put in as many zeros as you want, it doesn't matter. So when you say 1 doesn't go into 4, you put the decimal point under the decimal point and then you carry that 1 along. So how many times does 4 now go into 10? It goes in twice, remainder 2. How many times does 4 go into 20? It goes 5. That terminates. There's no more there. So the answer for a quarter, hopefully most of you remember 0.25. If you don't, that's how we do it. 7/8, okay? Again, 7 divided by 8. I'm hoping a few of you have also gone 0.000 like that. Okay, first question I asked myself, how many times does 8 go into 7? It doesn't. Put a 0. Put my decimal points under my decimal points. This is really, really important that these two sit directly underneath each other, okay? It's really, really important, guys. Really, really, really important, okay? Whoops, I've rubbed out half the stuff. Oh, well. Okay, because 8 doesn't go into 7, I carry the 7. How many times does 8 go into 70? Okay, 8 goes into 70 8 times. Okay, 8 8s are 64. Carry the 6. Okay, because there's 6 left over. How many times does 8 go into 60? Well, 8 goes into 67 times. Okay, with a remainder of 4. How many times does 8 go, oops, I was about to use the wrong colour. How many times does 8 go into 40? Well, actually, yay, it goes into 40 an even number of times. So my reoccurring decimal, or my decimal that, my terminating decimal, or my decimal that stops for 7/8 is 0.875. Okay. Okay, now this time you might notice that these won't be terminating decimals, they'll be reoccurring. Let me show you what I mean. This is saying 2 divided by 3. Okay, and we put our zeros, our decimal point, and we put some zeros to start ourselves off. How many times does 3 go into 2? It doesn't. 0. Decimal points under decimal points. Carry that 2. How many times does 3 go into 20? 3 goes into 20. 6 3s are 18 with a remainder of 2. How many times does 3 go into 20? Hold on, didn't I just do this? 6 with a remainder of 2. How many times just, wait, hold on, I keep on doing this for no reason. I just keep on getting 6. And if I keep on going, I'll forever, ever get 6. Okay? So what I need to do is, because that decimal is a reoccurring decimal, or it follows the same pattern over and over again, okay, I need to write it as 0. Now it's the 6 that keeps on reoccurring. I write the 6 there and I put a dot. That dot on top of it means reoccurring. Okay, Right, let's try this one. Whoa. 3 and 5/7. Now, I can't do 3 and 5/7 just like a mixed numeral. What I'm going to do is, well, I'm changing it to a decimal, okay? So what I'm going to do is I'm going to accept the 3. I'm going to put the 3 there. So I'm just going to ignore that 3 for the moment. Okay, and I'm going to do 5 divided by 7. Okay. Okay, so I'm going to write it up. 5 divided by 7. Okay. How many times does 7 go into 5? It doesn't. Decimal points under decimal points carry the 5. How many times does 7 go into, this time, 50? Okay, 7 7s are 49 with a remainder of 1. How many times does 7 go into? That's meant to be 10. Well, it goes once with a remainder of 3, so I'm going to have to do myself a few more zeros. Okay. How many times does 7 go into 30? Well, 7 4s are 28, so that's a remainder of 2. How many times does 7 go into 20? Well, 7 1s 7, 7 2s are 14, with a remainder of 6. How many times does 7 go into 60? Well, 7 8s are 54. Oh, sorry, 7 8s are 56, with a remainder of 4. How many times does 7 go into 40? Well, 7 goes into 40. 7 5s are 35. Okay, so with a remainder of 5. How many times does, oh, I've run out of some zeros. How many times does 7 go into 50? 7 goes into 50. Oh, hold on, I've seen this 5 before. 7 with a remainder of 1. Oh, there we go. Look at that. 5 1 5 1. I see a pattern. Okay, I have sensed a pattern. This is a repeating pattern. Okay, so I'm assuming if I did the next one, I'm going to have a remainder of 3. And if I did the next one after that, I'd have a remainder of 2. So my reoccurring decimal actually stops. This is this 7 here is a repetition of this 7, just as the next one would be a 1. So the pattern keeps on repeating. So as soon as I've got the same remainder, that pattern kept on repeating. So I cancel it out at that point. And this is how I write it. I'm going to rewrite it down here. 3.71428 Okay, and the repetition is on that 7 and on that 5. Okay, so I can either write it like that, or I can write it like that. Okay, either way would totally suffice. Okay, let's have a look at this. Round each of the following to the specific number of decimal places. So this guy here wants 3 decimal places. So here's my decimal point. Here's, I'll rub that out. Here's place 1, because that 3 is the first place value. Here's place 2. Here's place 3. The 7, the digit 7 is the third place value. I don't just cut it off and go, okay, that's good, those don't count. Okay, I have to do something really particular. For that digit that's next to the 7, so this 2, for example, that's the guy I care about. If he is 1, 2, 3, or 4, okay, that stays as 15.5. 3, 5, 7. If he was a 6, a 7, a 5, a 6, a 7, an 8, or a 9, this 7 would be changed to an 8. But as the case is, he is a 2, so that number rounded, that decimal rounded, is 3.57. Okay, let's have a look at this one to 4 decimal places. Here's my decimal point. That's place 1, place 2, place 3, place 4. Okay. When I have a look at this, I don't care about that. I care about the digit right to the next of it. Now, that is a 5, which means that 9 has to go up to a 10. Now, the issue that I'm going to have with that is because it's already 9, I can't just go up 1 more. I have to actually change all of my place values. Okay, so that 9, I therefore have to change my next place value. That's like 19. Because this one here next to my 4th place value is a 5, it goes up. So it actually becomes 4.86, not 19, but 20. 4.8620 is that one rounded to 4 decimal places. And that's it, guys. That's terminating, reoccurring, and rounding decimals.